Good morning, guys. Now I'm going to make a video presentation about a Cape-size vessel. Um, he's loading in Baltimore, in USA, of cargo, and he's, he'll, he's be loading coal and to a maximum of full load, and he has also a full bunker. So, mm, so let's start, guys. So this is a capesize vessel. So here's a summer draft. The summer draft, maximum summer draft is 18.23 meters, and his displacement is 234,842 metric tons. So we just concentrate on this summer draft, and he's going to has a displacement of 234,842. So what will be this maximum cargo to load? Okay, so let's check, guys. Let me see here. So since we are at birth, the local density at birth is 1.006. This will be the local density at birth in Baltimore. So since we have a drop of the summer drop is 18.23, and his displacement is 234,842. So what will be his displacement when you are floating in the local density of 1.006? Okay, so this is the formula, guys, to get the displacement when you are floating in 1.006. So displacement times the uh, constant of 1.025, or the salt water of the draft of 18.23 over your dead weight, which is this density of 1.006, or local density. That will be the displacement will be 234,842 times your salt water density of 1.025 over your local density of 1.006. So that will be 234,842 times this constant of salt water is 1.025. You have 40713.05 over your local density 1.06, and your top water density will be 239277. Okay, so that will be 239277. So what will be his corresponding drop will be 18.55. Okay, so from 18.23 salt water, or your summer drop, if you are floating in 1.006, your local water density, so that will be the corresponding drop will be 18.55, and your displacement will be 239277. So let's check, guys. I will go here. Okay, so let's go to the hydrostatic table. So the corresponding displacement was 239277. Okay, 239277. By interpolation, by interpolation, so the drop was That will be, see the displacement guy, 239277. 239277, and the corresponding drop is 239277, and the corresponding drop is 18.55. Okay, 18.55. And in the summer drop is 18.23. The corresponding drop is 234842. This is for 41.59. That will be 234842, which is, see the corresponding drop is 234842. Okay, this is already run up. So you have this drop is 234841.9 or 42. Okay, so that will be this corresponding displacement of this when you are plotting in a density of 1.0006. Your displacement should be 239277, and your drop will be 18.55. That will be if you're loading in a salt water, fresh duck water of 1.06. So let's go to Baltimore now, okay? Now we will use this Loadicator. Okay, we go to the Loadicator. This will be the Loadicator. Sorry. I think this one. 2, 3, 3. Okay, this one. So this will be the, I'm using now the Loadicator, but it usually shuts down, so I have to screenshot it so that it will not shut down. So we'll just make this a little bit bigger. Okay, so this will be the situation when your departure drop or main drop is 18.55. okay, so here you input here the storage factor as per your voice instruction. So you put here storage factor, the this will be the storage factor, and this will be your specific gravity of metric tons per cubic meter, and this will be your, that will be, forget the meaning of F, but this is your storage factor. Then once you put the storage factor, you will put here the percentage of the cargo. So you put here 100%, then try to put here 94 or 90%. Then you will get the cargo of, what important here is you will get this departure drop or main drop of 18.55 of the density of 1.066. okay, now I will show you the bunker. But the bunker will be this one. Yes, this is a little bigger. This should be your drop, departure drop of 18.55. Then your displacement is, look at the displacement with this drop, with your local density of 1.006. But look at the displacement. It's 2348,112. See? But it's different from what I have computed. It should be 239277 or 1855 should be 239277. But the Loadicator, the Loadicator, he has a different displacement, but he has the partial drop of 18.55. So which is strange to me, guys. So with this local density of 1.006, his displacement is different. But anyway, he got here the departure drop of 18.55. Okay, and this is and his cargo is 202 20,000 202 22,427.7, which is this one. Okay, and he has a zero balance, and his fuel is 4,576, which is almost full, and his diesel is 256.7, which is almost full, and has a fresh water of 243. Okay, and this will be his dead weight of 20788, and his light ship or lightweight is 26924. His constant is 380, and his provision is 5 metric tons. So I have a manual computation here. This one. Okay. So the local density at Baltimore is 1.006, which is port limit of 18.55. Okay. This will be the light ship. Displacement of your summer drop is 234842. Then this will be your ROV departure at Baltimore. Ballast is 0. Your fresh water is 243, which is this one. Ballast is 243. Fresh water is 243. This one. And your fuel oil is 4576. 4576. Fuel is 4576. And your diesel oil is 256.7. Diesel oil is 256.7, and your constant is 380, and your provision is 5 metric tons. So your constant is 380, and your provision is 5 metric tons. And you have a total, you have a total of non-cargo weight or ROB is 5460.7. Okay. Now, so what will be our maximum cargo to load? Okay. So I have here the salt water of your summer displacement. This is your local density. So this will be the displacement of the summer drop, and this will be the displacement of 18.55 of local density of 1.06. It should be 239277. Okay? If you follow this displacement of 18.55, which is I showed you a while ago, so with your displacement of 239277 minus your light shift, your dead weight will be 212353, and your ROB of 54660, which is this one, then your maximum cargo should be 206,892. Okay. But the Loadicator says your cargo should be 202,4227.7. So it's a quite difference. Okay. But this is what the Loadicator says. With this drop of 18.55, your cargo should be 202,4227.7. Okay, so what I did, just follow the Loadicator, which is which is this one. So look at this displacement of 234812. Displacement is 234812. So 234812 minus your light shape of 26924. This will be your dead weight and your ROB of 5460.7, which is this one, and your maximum cargo to load is 202,42,274. This should be 0.7. Okay, small difference. So I have already, this is what the loader master is, 202,4227.7, and I have the computed here of 202427.3, a difference of 0.4. Okay, so that's it. Now this should be his departure drop, and this should be his cargo. Okay, so what happens when you float? You're outside now the sea, open sea. So when you're in the open sea, so this is when you're in the open sea, your drop would be 18.23. Okay, this is a little bigger. When you're in the open sea, in salt water, your mean drop will be 18.23, your drop forward will be 70.96, and your up drop will be 18.49. You have a trim of 5.2. But look here, guys, I've got to tell you, this is 2.3. Okay, so this is your departure drop in at port. Your forward drop will be 18.33, and your drop out will be 18.76. You have a trim of 43 centimeters. Okay, and this will be your local density of 1.06. Look here, the deflection is 1.92 millimeter. That is 1.92 meters. So with this full cargo of 100% up from 2, hold number 2 to hold number 9 is 100%, meaning full cargo. So you cannot adjust you cannot adjust the deflection here. Deflection is sag. This blue line here, this should be your deflection sag. So you have a sag of 1.92 meters or 182 millimeter. Okay. So with this, look at the cargo is full. Number two is the same here, amount here. It is the maximum. And this will be your weight. The same. So meaning it's 100%. So there's no chance of adjusting the deflection. Okay. So meaning if you in hole number 5 you want to take out the deflection, you cannot adjust because all the holes are full. So you look at the outcome. Your shearing force is good, your normal and bending moment is good, and the allowance of 2 adjustment holes good, allowable JOM good. So this is a good uh, good system, or good your vessel is in a safety. Okay, with the departure drop of 18.55. And look at the graph here. So there's no problem with the shearing force and bending moments. Okay, with the departure drop of 18.55. So when you and when when you're in the open sea, you will go back to your drop of summer drop of 18.23. Okay, and your drop forward will be 17.96 and your up will be 17.49. But now your trim will be a little bigger of 0.52. When at port your trim was 43. Now you have 52, but you have the same cargo. The difference is you are now floating at seawater of 1.025. Okay, but you still have the same cargo and you still have normal shearing force, bending moments, normal good. So all good. Now your summer drop will be 18.23 when you are floating in a density of seawater of 1.025. Okay. Okay. Now for example, because you're loading now in a port in Baltimore. So what will be the pouring? So here in a capsize vessel, your trimming pour should be 5,000. Okay. So how do you convert this 5,000 into meters? Okay, for your trimming. So I made the program here. So your bore is 5,000. Your TPC is 138.73. So your trim your departure drop is 18.55, and his TPC is 138.73. So with your departure drop of 18.55, your TPC is 138.73. Okay, so with this computation, so your trim will be 138.73 and your pour is 5,000. So how do I convert this to uh, centimeters? So your Sinkage equals 4 divided by your TPC, which is 5,000 divided with your TPC 13873 is 36 centimeters. So with this 36 centimeters, you this departure drop 18.55 minus your 36 centimeters, then you have your mid drop will be 18.19, and your starboard will be 18.19, so your mid will be 18.19. Okay, so to give you an idea, so this will be your draft when you stop loading for trimming. So when you reach this drop of 18 meters forward and 18.30 up, and your mid will be 18.19, stop port and mid starboard will be 18.19. You stop and you will have to make a drop survey between you as chief officer and the drop surveyor. Okay, so you should have a sinkage of 0.36 meters or 36 centimeters. Okay, so since a I don't have a loading plan, I'll show you what I did. Okay, so that will be 1855. That will be, I made it like this. So 18.99, 18.19, 18.19. But with this drop, you don't have a trim. So you should have a trim. Okay? You cannot pop out your ballast with zero trim. So what I did was, I want to have a trim. So I make this as 18, 1810, 1810, and this will be 1829. 18.29. Okay, so you have a trim of 19 centimeters. So make this, let's say 30, 1830, 30, so about 20 centimeters. So you want to make it 30 centimeters, you make this 18. So you have a 30 centimeter trim. Okay, but still your sinkage is still 36. It's only your trim here that's changed, or your mean drop. So with this mean in your mid, you have a 4 centimeters hang. Okay, and with the with this sinkage of 36 centimeters, your recommended cargo for trimming will be 4,994.5. So with this recommended cargo, I made it a 5,000. Okay, so with 5,000, you pour 5,000 here. 1, 2, 3. Once you have loaded 5,000, your mid drop will be 18.55, which is the same, almost the same here, and your sinkage is 36.04, which was the same here. So with that, you go to trim holes 2, and your example, your trimming hole is 1 and 9. 5,000. You got 5,000 here and 5,000 here. Your trimming holes is 1 and 9. So how much will I load in hole 1 and 9 with a trim of 43 centimeters? Okay, 43 centimeters. Why? Because your departure drop in Baltimore with your mean drop of 18.55, your trim will be 43 meters, 0.43 meters. So with that, I make a trim of 0.43. Okay, so what will be my recommended cargo to load in hole number 1? So hole number 1 will be 2029. Okay, 2029. I put here 2029, and number 9 will be 2971. 2971. So when you load these cargoes, your departure drop will be, forward will be 18.30, and your forward drop will be 18.30, and your up drop will be 18.73, and your trim will be 43. See, check the departure drop at port. Forward is 18.33, and your up is 18.76, but your mean drop is 18.55. So you have a trim of 43. So with this, you have a trim of 43, and your forward is 18.30. But your mean, which is most important, is 18.55, and your mean is 18.15. You have a sag of 4 centimeters. Okay? But because your mean is 18.51, you have a sag of 4 centimeters. But the important here is 18.55. But according to the Loadicator, your deflection is 1.92 meters. With this graph, okay, look at the sag here, which is 1.92 meters here, the big sag. But according to my computation, your deflection should be 0.4 centimeters. Okay, it's up to you to decide, guys, which you would understand. But this is by one computation. Okay, according to my program. Okay, so that's it. Now, this will be, I have already explained this one. When you convert from your summer draft, what will be your draft if you are floating in density 1.016006, and you will have a displacement of 239277, and your draft should be 1855. But the Loadicator has a different displacement. His draft is 1855, but his displacement is the same, different, 238, 234812. But you have here, look at his maximum cargo to load is 2024227.7. But my computation for maximum cargo to load should be 206892 with your displacement of 239277, which is this one, 239277, and your light ship is 26924, dead weight is 21523, ROB is 5460, and this should be your cargo. But look at the dead weight here is 212353, but the dead weight will be 207888 with the draft of 1855. So we have I cannot understand why his displacement is 234812 when actually your displacement uh, your dis your displacement should be 239227, okay, with this drop of 1855. So look at here, 1840 is, sorry, 1840 is 23719956, okay. So 23719996, and your 1860 is 239974. 1860 23990402 997402. Two three nine nine 2. So we interpolate it. This should be your corresponding drop or displacement of 239277, which is the same with this one, 23999277. Okay, but I don't understand why he has a different displacement. Okay, and you have a cargo of this one. So what I'm trying to say here, guys, is that you input here this search factor or whatever the voice instructions is, and he has a recommended of search factor. You put it here, or the specific gravity of the cargo. Once you input the search factor, you will have automatic here the maximum weight, and he will also produce this weight here. But if you put the percentage, once you put 100, 100, you will automatically input here by this Loadicator. So it's the same because it's 100, the same is 100. And you will have, you will adjust and hold number 1, adjust your hold number 1 for your trim, what you want your trim to be. Okay, look at to, and you have the cargo. Look at the trim here of maximum drop of 18.55, your trim is 0.43. What happens if you go to the OpenSea if your drop is 18.23? Okay, your drop will be 18.52. So there's an increase of your trim, and you have a change of drop forward will be a 17.96. Your main drop is 18.23 with the summer drop, and your after drop is 18.49. And you have your density is 1.025 and your deflection is 1.87. Okay, here, and look, we still have this deflection here, sag, sag. So that's it, guys. I have an interpolation here with your, I'm sorry, with how to get this displacement of 18.55. So you have here 1840, 1860, and the final I have 239280. But it's only about 3 tons difference because I have here 280.4 and my computation is 239277. That one was 80, but I use this one because we have the same with my program, 239277. Okay, so I hope, guys, you would understand or like this video. It's red because it's more than 18 point of the summer drop. That's why it's red. Okay, so that's it, guys. I hope you like this video presentation. If you like, please click the like button, share, and subscribe. And don't forget to click the notification bell. Thank you for watching.